Okay. So now, first of all, what about cycloaddition reaction? Now, first of all, today our point of discussion, what about cycloaddition reaction, right? So you people can see, I think now the PPT is visible for all, right? Cycloaddition reaction means that reaction where two molecules, right, participate. Minimum two molecules required for cycloaddition reaction, right? So for cycloaddition reaction, one of the important point is we require minimum two molecule. For that reaction, we require minimum two molecule, right? So if there are two molecules, then the reaction is a cycloaddition reaction. And if there is not two molecule, then we can't say the reaction is a cycloaddition reaction, right? So first thing related to cycloaddition reaction, there should be minimum two molecule. There should be minimum two molecule, right? So second thing is cyclic compound, right? The final product should be a cyclic product. Final product should be a cyclic product, right? So this is also important point related to cycloaddition reaction. This is also important point related to cycloaddition reaction. So two molecules required, right? And cyclic transition state required for this reaction. Cyclic transition state required for this reaction, right? Now, if we talk about reverse reaction, so then this is called cyclo-reversion reaction or ring cleaving reaction, right? So because sometime your reactant convert into a cyclic product, and sometime your cyclic product come back into a cyclic product, right? So in this way, there is also reverse process, right? And this reaction is actually, you can say the reaction is a reversible reaction. This reaction, we can say the reaction is a reversible reaction. This reaction is a reversible reaction. So it should be clear, right? So cycloaddition reaction, first of all, there are two molecules combined together and then they convert into a finally cyclic compound, right? And you people already know during this reaction, right? One cyclic transition state form, right? This is basic requirement of pericyclic reaction, right? This reaction is reversible reaction, so there is not only forward reaction, there is also reverse reaction, and that is called cyclo-reversion or ring cleaving reaction, right? So ring cleavage or ring cleaving reaction, it means your cyclic compound convert into a cyclic compound, right? Not all cycloaddition reaction, not all cycloaddition reactions are pericyclic reaction. It is also important point related to cycloaddition reaction, right? This is also important point related to cycloaddition reaction, right? All reaction where final product is cyclic, right? All reaction where final product is cyclic, it's not compulsory that those all reactions are pericyclic reaction, right? So it should be clear, right? There are so many reactions where the final product is a cyclic product which formed from a cyclic compound, right? But that though all those reactions are not part of pericyclic reaction. Now we take some examples, right? For example, you can see here diradical intermediate, because the basic requirement of pericyclic reaction is there should be a cyclic transition state. There should be a cyclic transition state. So you can see this reaction, right? This is your ketone. When ketone react with olefine, either this type olefine or this type olefine, then they convert into intermediate. Then they convert into intermediate, and intermediate like this. Intermediate like this. This is 1,4 diradical intermediate. This is 1,4 diradical intermediate, right? And when formed 1,4 diradical intermediate, right? At the end, the compound convert into a final product, and this product is called oxetine. This product is called oxetine. It is one of the important photo chemical reaction because the reaction takes place in presence of photon. The reaction takes place in presence of photon, and the final product is actually cyclic product, right? And that is very famous compound and called oxetine. That is very famous compound, right? You can see here, right? The reaction ketone react with olefine, they convert into 1,4 diradical. They convert into 1,4 but diradical. So because here the intermediate is diradical, here no cyclic intermediate, because here no cyclic intermediate, so the reaction is not part of cycloaddition reaction, and the reaction is not part of pericyclic reaction. It is cycloaddition, you can say it may be cycloaddition reaction, but it is not actually pericyclic reaction, because the pericyclic reactions are those reactions where delta S value should be negative, and it is only possible if our intermediate is cyclic in their nature, right? It is only possible if our intermediate is cyclic in their nature. Now after that, you can see other one compound enone, right? This is enone. Why we call that enone? Because here double bond along with, right, carbonyl group. So en and on, right? So it is called enone. The compound is called enone, right? The compound is called enone. So when enone react with olefine, either this types or this type, they both are isomer, right? They both are isomer. So if they react with olefine, then they convert into this types of intermediate, right? It is also 1,4-diradical. It is also 1,4-diradical, and at the end they convert into cyclobutane, right? They convert into cyclobutane type of compound, right? So this reaction, you can see here also 1,4-diradical formed. Here also 1,4-diradical formed. Here the reactant not convert into a cyclic transition state. Here also the reactant not convert into a cyclic transition state. They convert into 1,4-diradical. And because they convert into 1,4-diradical, so this reaction actually not pericyclic reaction or cycloaddition reaction, right? So because of not formed your cyclic transition state, so you can see here, right? So these are one of the important example where two unsaturated acyclic compound react and then they finally convert into a cyclic compound, but this is not part of pericyclic reaction, or these reactions are not part of pericyclic reaction. Now we can take some other example also. Not only this example, you can see here, right, some more examples, right? Sometime zwitter ion as a intermediate, right? Sometime zwitter ion as a intermediate. You people already know about zwitter ion, right? That intermediate where at same intermediate positive and negative charge, that is called zwitter ion, right? So you can see this example here. You can see if your enamine means here double bond along with amine group, right? So if there is you can see if there is enamine, right? Right, it is electron rich compound. You can see it is electron rich compound. Why? Because of lone pair of electron along with double bond, right? So pi bond, right? Here pi bond along with, you can see lone pair of electron, right? So if this is our compound enamine, right, one compound electron rich compound or behave like a nucleophile enamine react with other one compound, it is electron poor compound. Because you can see here at alkene CN group, and cyno group is electron withdrawing in their nature, right? Cyno group is electron withdrawing in their nature, and if two electron withdrawing group attach at this ene, right, so then you can say electron deficiency always at this alkene, right? And then we can say this is electron poor compound. We can say it is electron poor compound. Why electron poor compound? There is pi bond, but the problem is two electron withdrawing group attach at this pi bond, right? So there is deficient because they always withdraw electron from pi bond, right? तो वो हमेशा क्या करेंगे, पाई बॉन्ड से इलेक्ट्रॉन को खींचेंगे, और इसलिए इस कंपाउंड पर इलेक्ट्रॉन की क्या होगी, डिफिशियंसी होगी, एंड दे बिहेव लाइक ए इलेक्ट्रोफाइल, और इसलिए क्या बिहेव करेगा, इलेक्ट्रोफाइल की तरह बिहेव करेगा. Now, if these two compounds react, it's a very feasible or spontaneous reaction, right? Here one electron rich and other electron poor compound, when they react, right? And in thermal condition, when they react, then they convert into zwitterion. You can see here, right? This is amine part, right? Now this lone pair of electron convert into bond pair of electron. Lone pair of electron convert into bond pair of electron, right? And then because lone pair of electron of nitrogen convert into bond pair of electrons, so their positive charge. So at nitrogen, their positive charge, right? And after that, you can see, right, because this pi bond convert into sigma bond, you can see this pi bond convert into sigma bond, right? And then this pi bond come at this place, right? And when they convert into negative charge, then they finally convert into a zwitter ion, right? Then you formed intermediate, and that intermediate is actually called zwitterion, right? Then they convert into intermediate, and this intermediate is actually called zwitterion, right? So how your reactant convert into zwitterion, and after that you can see formed sigma bond between this carbon and this carbon, formed sigma bond between these two carbon, right? So because here this this pi bond come back into lone pair of electron, right? This pi bond come back into lone pair of electron, and then this negative charge convert into sigma bond between these two carbon, right? So you can see cyclobutane, they convert into a product cyclobutane, right? They convert into a product cyclobutane, right? So you can say acyclic compounds, unsaturated acyclic compounds convert into a cyclic compound, but the reaction is not example of pericyclic cycloaddition reaction, right? But the reaction is not example of pericyclic cycloaddition reaction. Why? Because their intermediate is zwitter ion, right? And here intermediate is zwitter ion, but for pericyclic reaction required intermediate that should be cyclic, right? That should be cyclic transition state. And delta for this reaction, always delta S value should be positive, right? So there would be positive, right? So there always delta S value positive for this reaction. But if we talk about pericyclic reaction, then their delta S value would be a negative, right? That would be negative, right? So it should be clear, right? Here what is condition and here what is condition, delta S value, because here a cyclic intermediate and here cyclic intermediate, right? Now after that you can take next one example, right, where the final product is cyclic, but the intermediate is not cyclic transition state. So this is also not example of a pericyclic cycloaddition reaction. You can see here in ether, right? In ether, right? It is electron rich compound. Why? You know, in ether, right? Methoxy group attach at alkene, right? So you know methoxy group is electron donating in their nature. Methoxy group is electron donating in their nature. जो methoxy group होता है वो electron donating nature का होता है. जब दो दो electron donating nature के group alkene पर लगे होंगे तो जो एल्कीन आपका होगा वो बहुत ही ज्यादा इलेक्ट्रॉन रिच होगा, उसके पास बहुत ज्यादा इलेक्ट्रॉन क्या होगी, डेंसिटी होगी. तो एक कंपाउंड तो आपको मिल गया इलेक्ट्रॉन रिच, वेयर एल्कीन कनेक्टेड विद टू इलेक्ट्रॉन डोनेटिंग ग्रुप, दे आर methoxy group, right? And second one you can see it is electron poor, same like this. It is electron poor where cyno group attach at double bond, or alkene where cyno group attach at alkene, right? And then same here, one electron rich and second electron poor, they react together, right? So then methoxy group give their lone pair of electron, and then they convert into pi bond, add methoxy come positive charge, same, right? And after that this pi bond move in this direction, right? Then there is sigma bond, and then this pi bond come at this place, then there is negative charge, right? So in this way they convert into a intermediate, right? Like a zwitterion, they convert into intermediate like a zwitterion where one side positive and second side negative, right? Now after that same like this, right? This negative charge convert into sigma bond, and then this pi bond come back into a lone pair of electron, and then they convert into cyclobutane. So this is the reaction. Where because the cyclic transition state is not formed, because here cyclic transition state is not formed. This is region, it is not example of pericyclic cycloaddition reaction, right? So this is the reaction where in ether react with germinal dicyanoethane. Germinal dicyanoethane is electron poor compound and in ether is electron rich compound, and in above reaction in amine is electron rich compound and germinal dicyanoethane is electron poor compound. So they can react in this way. They formed zwitterion as an intermediate, and these two reactions are thermolysis, right? These two reaction takes place in presence of thermal conditions, right? And finally the product formed, that is cyclic product, and cyclobutane form, then form is cyclobutane. So this is important reaction, but they are not pericyclic cycloaddition reaction, reaction. So this is important point related to non-pericyclic reaction. They are in these reaction acyclic unsaturated compound convert into cyclic compound, but these are not pericyclic cycloaddition reaction. Now these are the example of pericyclic cycloaddition reaction. You can see here, right? 2+2 cycloaddition reaction. We already know, right? When two ethylene molecule react, then they finally convert into a cyclobutane. And this reaction pass through concerted manner, right? These reaction pass through concerted manner where simultaneously bond breaking, bond formation process, right? And there is no cyclic transition. There is cyclic transition state. So it is an example of pericyclic reaction. If you think about Diels-alder reaction, very famous reaction, I will discuss that in coming PPT also, right? So when you can see here, right, butadiene react with ethylene, then 4+2 cycloaddition reaction, and they finally convert into cyclohexene, right? This is also a pericyclic reaction because same thing, concerted types of reaction, simultaneously bond breaking and bond formation process, and they are also cyclic transition state, Now after that you can see 4 pi plus 4 pi, right? It is also important, not famous cycloaddition reaction, but it is also one of the important example of cycloaddition reaction, pericyclic cycloaddition reaction, right? Where 2 butadiene react and then they convert into this types of cyclic product, right? So they also follow concerted manner and cyclic transition state. So they are also example of pericyclic cycloaddition reaction. So these are three important example of pericyclic cycloaddition reaction: 2+2, 4+2, and 4+4, right? Now after that, concerted 2+2 cycloaddition reaction of alkene. We have already discussed 2+2 cycloaddition reaction of alkene, where two ethylene molecule react and then they finally convert into cyclobutane. So this is the reaction. Normally reaction takes place in presence of sunlight. I already told, right? Because the number of electrons are not follow Huckel rule, because the number of electron not follow Huckel rule, right? जो number of electron होते हैं वो Huckel rule को follow नहीं करते, 4n+2 rule को follow नहीं करते हैं. तो इसलिए क्या होती है, reaction जो होती है, right? ये reaction thermally नहीं होती है, because मैंने पहले भी कहा according to PMO method, right? If compound follow aromaticity and if their if they follow Huckel rule, right, 4n+2 pi electron rule, right, so then they are thermally allowed, right? Otherwise they need to use photochemical condition, right? तो अगर Huckel rule के according electron है तो फिर वो रिएक्शन, फॉर एग्जांपल अगर मैं Diels-alder रिएक्शन की बात करूंगा तो दैट इज थर्मल रिएक्शन. व्हाई? बिकॉज द नंबर ऑफ इलेक्ट्रॉन पार्टिसिपेट दे आर 6, 4+2 6, राइट? तो वो तो आपकी थर्मल कंडीशंस में हो जाएगी. बट 2+2 cycloaddition reaction is not thermal reaction, it is a photochemical reaction. अब photochemical reaction कैसे होती है? You people, I think we had already discussed about photochemistry. No, right? Photochemistry is in next semester course, right? That is a course in next semester. So I will elaborate photochemistry, right? But here we just only understand, right? Because the number of electrons are only 4, so they not follow Huckel rule. So the reaction not takes place in presence of thermal condition. The reaction normally takes place in presence of photochemical condition. It means we required minimum 1 photon energy for this reaction, for proceed this reaction, right? तो इस रिएक्शन को प्रोसीड करने के लिए हमें कम से कम 1 फोटोन एनर्जी की रिक्वायरमेंट होती है, राइट? आउट ऑफ 2 इथिलीन, 1 इथिलीन एब्सॉर्ब 1 फोटोन एनर्जी, देन दैट गोज टू सिंगलेट एक्साइटेड स्टेट। एक दोनों में से एक क्या करेगा, एक फोटोन एनर्जी को एब्सॉर्ब करेगा, देन दे गोज in a singlet excited state, and then that react with other one ethylene molecule, and then they convert into a final प्रोडक्ट, राइट? तो जो ट्रांजिशन स्टेट होगी उसमें क्या होगा, आउट ऑफ 2 एक जो मॉलिक्यूल इथिलीन का होगा वो 1 फोटोन एनर्जी को एब्सॉर्ब करेगा, एंड देन दैट गोज इन सिंगलेट एक्साइटेड स्टेट। वो किस में जाएगा, सिंगलेट एक्साइटेड स्टेट में जाएगा, राइट? अगर आप चाहते हो कि रिएक्शन ट्रिपलेट एक्साइटेड स्टेट से होके जाए, राइट, बिकॉज यू पीपल नो सिंगलेट और ट्रिपलेट 2 टाइप की एक्साइटेशन स्टेट होती है, राइट? तो देयर आर 2 टाइप्स ऑफ स्टेट, वन इज कॉल्ड सिंगलेट स्टेट एंड सेकंड इज कॉल्ड ट्रिपलेट स्टेट। अब सिंगलेट स्टेट में क्या होता है और ट्रिपलेट स्टेट में क्या होता है, व्हाट इज डिफरेंस बिटवीन सिंगलेट स्टेट एंड ट्रिपलेट स्टेट? व्हाट इज डिफरेंस बिटवीन सिंगलेट स्टेट एंड ट्रिपलेट स्टेट? सिंगलेट स्टेट में क्या होता है, दोनों के दोनों इलेक्ट्रॉन जो होते हैं वो अपोजिट डायरेक्शन में होते हैं, राइट? दोनों के दोनों इलेक्ट्रॉन जो होते हैं वो क्या होते हैं, अपोजिट डायरेक्शन में होते हैं। एक अगर क्लॉकवाइज होगा तो दूसरा क्या होता है, एंटी क्लॉकवाइज होता है, राइट? इफ वन इलेक्ट्रॉन इन क्लॉकवाइज देन अदर इलेक्ट्रॉन इन एंटी क्लॉकवाइज, इट मींस दे फॉलो अबाउट पाउली एक्सक्लूजन प्रिंसिपल, राइट? पाउली एक्सक्लूजन प्रिंसिपल को फॉलो करेगा, एक क्लॉकवाइज डायरेक्शन में होगा, एक एंटी क्लॉकवाइज डायरेक्शन में होगा। लेकिन ट्रिपलेट में क्या होता है, ट्रिपलेट में क्या होता है, दोनों के दोनों इलेक्ट्रॉन जो होते हैं वो एक ही डायरेक्शन में होते हैं। अगर एक क्लॉकवाइज होगा तो दूसरा भी क्या होगा, क्लॉकवाइज होगा, राइट? इफ फर्स्ट वन इज इन क्लॉकवाइज डायरेक्शन देन अदर आल्सो इन क्लॉकवाइज डायरेक्शन, अदर आल्सो इन क्लॉकवाइज डायरेक्शन, दूसरा भी क्या होगा, क्लॉकवाइज डायरेक्शन में होगा, राइट? तो अगर ये कंडीशंस होती है कि दोनों के दोनों क्लॉकवाइज डायरेक्शन में है, राइट, तो देन दिस इज कॉल्ड ट्रिपलेट एक्साइटेड स्टेट। अब अगर आप कहोगे हाउ कंपाउंड गिव रिएक्शन इन ट्रिपलेट एक्साइटेड स्टेट, कंपाउंड किस तरह से ट्रिपलेट एक्साइटेड स्टेट में रिएक्शन देगा, तो फॉर दैट वी रिक्वायर्ड सेंसिटाइजर, राइट? उसके लिए हमें सेंसिटाइजर चाहिए। सेंसिटाइजर क्या होते हैं, कार्बोनिल कंपाउंड होते हैं, राइट? वो क्या करते हैं, एक फोटोन एनर्जी को एब्सॉर्ब करते हैं, देन दैट गोज इन सिंगलेट एक्साइटेड स्टेट, एंड देन they release a small amount of energy, then come back from singlet excited state to triplet excited state, and then they transfer their energy to our alkene, right? And then our alkene goes in triplet excited state. तो अगर आप चाहते हो कि आपकी जो पेरिसाइक्लिक साइक्लोएडिशन रिएक्शन है वो ट्रिपलेट स्टेट में हो, तो उसके लिए आपको सेंसिटाइजर का यूज करना पड़ेगा। तो इफ यू वांट योर 2+2 cycloaddition reaction takes place in presence of a triplet state, then you require some sensitizer for that reaction. Especially carbonyl compound behave like a good sensitizer. I will discuss that in our next semester chemistry, right? And that is very important chemistry called photochemistry, right? Photochemistry कहते हैं। तो नेक्स्ट सेमेस्टर में जो कोर्स है उसमें इसके बारे में बहुत डिटेल में डिस्कशन है, पूरा यू कैन से दैट हाफ ऑफ द कोर्स रिलेटेड टू फोटोकेमिस्ट्री। जैसे एक्चुअली होता क्या है, पेरिसाइक्लिक एंड फोटोकेमिस्ट्री की एक पूरा का पूरा एक कोर्स होता है, राइट? 50% पेरिसाइक्लिक रहता है और 50% फोटोकेमिस्ट्री रहता है, बट यहाँ पे जो डिजाइन किया गया है उसमें पेरिसाइक्लिक को अलग और फोटोकेमिस्ट्री को अलग किया गया है। कोई बात नहीं, no problem, we will discuss that in next semester, right? Okay, so you can see this is a little bit out of the point, right? And but it is important for cycloaddition reaction also. Okay, after that you can see acyclic cis trans isomer, right? Acyclic cis and trans isomer, supra supra interaction, and then they give final product, and the product is highly stereospecific. जैसे कि मैंने आपको कहा, चाहे सिस हो चाहे ट्रांस हो, कोई भी आइसोमर हो, सिस हो सकता है या ट्रांस हो सकता है, कोई भी आइसोमर हो, तो वो सुप्रा सुप्रा मतलब एक ही साइड से इंटरेक्शन करता है। क्या करते हैं, सुप्रा सुप्रा। अगर सुप्रा सुप्रा इंटरेक्शन होगा तभी जाकर के क्या बनेगा, फाइनल प्रोडक्ट बनेगा, राइट? सुप्रा इंट्रा नेवर गिव फाइनल प्रोडक्ट, supra intra never give product, right? So it means it is a highly stereospecific reaction. I have already discussed that when we talk about Woodward-Hofmann rule for PMO method, right? जब मैंने Woodward-Hofmann rule आपको क्लियर किया था PMO method में, तब मैंने डिस्कस किया था when supra interaction, then the process is feasible and at the end you produce a final product, right? तो highly stereospecific होती है. These reactions are highly stereospecific. These reactions are highly stereospecific. Why these reactions are highly stereospecific? Because only supra interaction is feasible. केवल supra interaction ही क्या होता है, feasible होता है, right? तो इसलिए ये reactions हम कहते हैं it is you can say that a very stereospecific reaction, right? Now next point, अब हम ये करते हैं कि एक reactions को लेते हैं, right? जो normally बहुत ही ज्यादा famous है, Diels-Alder reaction. For that the scientist Diels and Alder got a Nobel Prize in 1950, right? तो 1950 में Diels and Alder ने मिल करके एक reactions को generate किया जिसका नाम Diels-Alder reaction होता है, and for that reaction they got Nobel Prize in 1950. तो 1950 में उनको इसके लिए क्या मिला था, Nobel Prize मिला था, right? Because this reaction is a very stereo selective reaction, right? कुछ reactions क्या होती है, बहुत ज्यादा specific होती है, एक स्पेसिफिक प्रोडक्ट ही एक स्पेसिफिक रिएक्शन से मिलता है, तो उस रिएक्शन की ऑर्गेनिक केमिस्ट्री में बहुत ज्यादा वेटेज हो जाती है. जैसे होता है ना, कोई मेडिसिन है वो स्पेशली एक बॉडी के पार्ट पे आपका अटैक कर दिया, हार्ट की मेडिसिन हार्ट पे ही अटैक करे, वो किसी और ऑर्गन को अफेक्ट ना करे, तो फिर उससे बढ़िया मेडिसिन कुछ नहीं हो सकती है और उसका और किसी पार्ट पे इफेक्ट नहीं पड़ेगा. तो स्पेसिफिक टारगेट पे अगर कोई रिएक्शन रिएक्ट करती है और कोई एक ही प्रोडक्ट देती है, तो फिर उसकी जो वैल्यू होती है मार्केट में वो बहुत ज्यादा बढ़ जाती है, राइट? तो इसीलिए जो Diels-Alder रिएक्शंस है उसको बहुत ज्यादा वेटेज मिलता है, एंड फॉर दैट दिस साइंटिस्ट गॉट नोबेल प्राइज इन 1950, राइट? तो नाउ व्हाट इज इंपॉर्टेंट पॉइंट, यू कैन सी cis conjugated dienes and dinophile, right? 6 member ring, right, convert into a final product. तो Diels-Alder reaction आपको पता है, right? Butadiene react with ethylene and then they convert into cyclohexene, right? So if butadiene is a cis type, तो cis conjugated dienes basic requirement is cis conjugated diene. आपके पास cis type का होना चाहिए, trans type का होगा तो then they cannot convert into final product. We require cis type diene, right? And other one is dinophile, और दूसरा क्या होना चाहिए, डाइनोफाइल होना चाहिए, राइट? जैसे इथिलीन होता है तो इथिलीन डाइनोफाइल का वर्क करता है, और एक कॉन्जुगेटेड जो ब्यूटाडाइन जो होता है वो आपका डाइन का वर्क करता है, और आपका दूसरा जो इथिलीन होता है वो डाइनोफाइल का वर्क करता है. ये इलेक्ट्रॉन रिच माना जाता है ब्यूटाडाइन जो है, राइट? तो ये बिहेव करता है एज ए यू कैन से दैट न्यूक्लियोफाइल, एंड ये जो डाइनोफाइल होता है ये इलेक्ट्रॉन पुअर माना जाता है, एंड इट बिहेव लाइक ए इलेक्ट्रोफाइल, राइट? जब एक न्यूक्लियोफाइल एक इलेक्ट्रोफाइल से रिएक्शन करता है तो देन दे फाइनली कन्वर्ट इनटू ए साइक्लिक प्रोडक्ट, राइट? So now you can see there are several rules related to Diels-Alder reaction. Out of that one rule you can see diene as cis conformation, diene as cis conformation, right? So this is important one rule, right? Diene as cis conformation reactive in cyclic, also in trans the large distance, so trans is not allowed for Diels-Alder reaction. Trans should be converted into cis, trans को cis में convert होना पड़ेगा, तब जाकर के ही वो Diels-Alder reaction को देगा. तो कहने का अर्थ ये है, अगर आपके पास S trans है और एक S cis है, S means single bond between these two single bond, तो सिंगल बॉन्ड है, यहाँ पे देखो ये सिंगल बॉन्ड है, राइट? तो एस एस इसलिए हमने यूज किया. ट्रांस क्यों है? बिकॉज वन दिस साइड एंड अदर दिस साइड, दोनों की जो लोकेशन है वो क्या है, डिफरेंट है, एंड दे आर फार फ्रॉम वन अनदर. आप देखिए यहाँ पे ये और ये क्या है, एक दूसरे से बहुत दूर है, एंटी पोजिशन पे, राइट? तो दे नीड टू रोटेट, इनको आपको रोटेट कराना पड़ेगा एस सिस में, सिस में, एस सिस में इसको रोटेट कर. अगर ये आपका एस ट्रांस है तो दे नीड टू रोटेट इनटू एस सिस, एंड बिकॉज सिंगल बॉन्ड बिटवीन दीज टू कार्बन देन इट्स पॉसिबल, राइट? बिकॉज इन दो कार्बन के बीच में सिंगल बॉन्ड है तो ये पॉसिबल है कि वो रोटेट हो सके. आपको पता है ये सिंगल बॉन्ड होगा तो दे कैन गिव फ्री कन्फर्मेशन फॉर्म, तो वहां पे फ्री रोटेशन हो जाएगा. तो सिस कैन, ट्रांस कैन कन्वर्ट इनटू सिस एंड सिस कैन कन्वर्ट इनटू ट्रांस. because basic requirement for Diels-Alder reaction, dienes should be cis, राइट, डाइन सिस होना चाहिए। तो इसलिए आप इस ट्रांस को रोटेट करके ये ट्रांस अपने आप ही सिस में कन्वर्ट हो जाएगा। देन दे आर feasible for Diels-Alder reaction. Then they are feasible for Diels. So this is first rule, right? So diene should be and S cis, right? वो S cis होना चाहिए, right? Single bond between two carbon होना चाहिए, and then if S cis, then they are feasible for Diels-Alder reaction, otherwise not, right? तो अगर क्या है, if your compound is cyclic, अगर आपको जो ब्यूटाडाइन है वो अगर साइक्लिक कंपाउंड, right? If butadiene is cyclic compound, then there not possibility of free rotation. फिर यहाँ पे free rotation की possibility नहीं होती है. In that condition, if cis, right, cis conformation, then that feasible, then that very reactive for Diels-Alder reaction. But if that is trans type, you can see if they are trans type like this, they are trans, right? So then because here free rotation is not possible, यहाँ पे फ्री रोटेशन पॉसिबल नहीं है, राइट? तो रोटेशन इज प्रिवेंटेड इन साइक्लिक एल्कीन. साइक्लिक एल्कीन में जो रोटेशन होता है वो नहीं हो पाता है, इसलिए जो ट्रांस होगा साइक्लिक ब्यूटाडाइन जो ट्रांस नेचर का होगा, दैट नेवर रिएक्ट इन Diels-Alder रिएक्शन. तो दिस टाइप्स कंपाउंड और दिस टाइप साइक्लिक डाइन नेवर पार्टिसिपेट इन Diels-Alder रिएक्शन. तो इस टाइप का जो आपका ट्रांस डाइन होगा वो कभी भी पार्टिसिपेट नहीं करेगा. इट इज अनरिएक्टिव इन Diels-Alder रिएक्शन. बट दिस टाइप, इट इज सिस टाइप एंड साइक्लिक, इट इज हाईली रिएक्टिव, राइट? इट इज वेरी रिएक्टिव for Diels-Alder reaction, right? So cyclic compound mein because free rotation is not possible, right? Because in cyclic compound free rotation is not possible, so only cis type conformation participate while trans type conformation never participate, right? So this is one of the important points related to Diels-Alder reaction, and you can say it's one of the important rule for Diels-Alder reaction, right? After that, what is next important point? So you people, I have already told, if two compound, one is butadiene and second is ethylene. You know, if there is two compound, one is butadiene and second is ethylene, right? So one behave like a nucleophile where two pi bond, and second behave like a electrophile where only one double bond, right? So what is important thing? Because one behave like a nucleophile, other behave like electrophile. Electrophile means there should be deficiency of electron, right? So if electron deficiency at electron deficiency at alkene, right, then that behave like a good then that behave like a good dienophile, right? So then if it means how we decrease electron density at alkene, हम alkene पर electron density को कैसे decrease कर सकते हैं जब हम किसी electron withdrawing group को उस पे attach कर देंगे. तो you can see if electron withdrawing group attach at ethylene, right? ये ethylene है, राइट? अब इस पे आपने एक इलेक्ट्रॉन विड्रॉइंग ग्रुप अटैच कर दिया, द जेड में भी इलेक्ट्रॉन विड्रॉइंग ग्रुप, एंड देन दे विड्रॉ इलेक्ट्रॉन एंड देन देयर इज अ डिफिशिएंसी ऑफ इलेक्ट्रॉन, इलेक्ट्रॉन पुअर हो जाएगा, राइट? इफ देयर टू इलेक्ट्रॉन विड्रॉइंग ग्रुप, देन द डिफिशिएंसी ऑफ इलेक्ट्रॉन इंक्रीज, राइट? एंड देन दे बिहेव लाइक ए गुड डाइनोफाइल. इस तरह से वो क्या करेगा, बहुत अच्छे डाइनोफाइल की तरह वर्क करेगा, एंड देन दे इंक्रीज रिएक्टिविटी, राइट? यू कैन सी इफ वी मूव फ्रॉम ethylene to this and then this, where one electron withdrawing group, then two electron withdrawing group, so then reactivity gradually increase, right? So reactivity क्या होती है, gradually increase होती है, right? So you can see electron withdrawing group increase the reaction rate, right? Electron withdrawing group increase the reaction rate, right, of Diels-Alder reaction, right? So diene nucleophile, right? Dienes, you know, a butadiene that behave like a nucleophile, and dienophile behave like an electrophile. So for dienophile, low electron density is good, right? So within 1 minute the link will expire, then we will rejoin at same link, right? तो हमने फिर से 1 मिनट के अंतर्गत जैसे लिंक एक्सपायर होगा हमने फिर से रिज्वाइन करना है, राइट? तो ये आप ध्यान रखना, विदिन 1 मिनट लिंक एक्सपायर हो जाएगा. तो more electrophilic, if more electrophilic, right, or if strong electrophilic, then that is good for Diels alder reaction. Z is an electron withdrawing group. I already told Z behave like a electron withdrawing group, right? So more electrophile, if there is more electrophilic nature, right? Electrophilic nature agar strong hoga, more hoga, so then they good or they feasible for Diels alder reaction, right? Because dinophile here behave like